Good morning, class. Dr. Zen. Welcome to week 4 of the class. In this week, we are going to focus on a couple of things related to software development, as well as the programming languages used for software development. So, the agenda for this week is first we will discuss things related to program or software development lifecycle. Sometimes you see that as SDLC, sometimes you read that as PDLC. It all depends on whether you want to focus on the program itself or the software. Then we're going to talk about an important concept in software engineering as well as programming is the role of algorithm. How you decide what to do using the computer software or computer program. And then you can put that into codes. Then we're going to go over quickly on some of the popular programming languages, especially how do you differentiate between different generations of programming language. And we will focus on one particular language, which is the Python language we will use in your assignment 3. And you probably already got some of those ideas after watching some of the health informatics research seminars, especially related to data science. Python become a more popular language in that area. So first is programming development lifecycle. EMR is a program. It's a huge software. It's an enterprise level software, allow you to manage all the information within enterprise. Of course, EMR could be a small scale in a small office. It could be a larger scale in a huge multi-specialty hospital. If you work on the vendor side, you're probably going to involve into development a lot more on the user side, which most likely you're just going to focus on the implementation or installation of the software. But nevertheless, knowing how software is developed will be helpful as a health informatics students for you to understand the process and for you to understand why you can't just submit a feature and get it fixed right away, because there is a established way to develop software in computer science. Alright, so the system development life cycle, which is a larger cycle than the program development life cycle. When we say system, it means the entire information system. So for example, if the medical center here in Vidon wants to have a EMR to be built in-house, alright, just imagination. If you work for a medical center, they wanted to have in-house EMRs. So they needed to start all the way from initialization. So they need to have a group meeting at the C level. Just say, well, it seems we need to make a strategic decision on whether we wanted to make the software in-house or we wanted to have external vendors to come in and install the software or install the system for us. So if they decide to install a system, develop a system in-house, they need to initialize it. They needed to develop the system concept. So which means they needed to define the scope or the boundary of the concepts, include system boundary documents, cost-benefit analysis, risk management plan, and a feasibility study. So they need to see whether it's viable for them to do that kind of thing, to have a in-house health information system. Then they need to move on to the next stage, which is the planning stage. Planning stage will allow them to start to plan the information system. So all they needed to have now is to have a project management plan, which you will learn more in the course 6550 if you are in the MS program. And other planning documents, basically like Gantt charts and milestones, project teams, all those kind of things you need to start to prepare. So how do you form a team? How do you set up milestones? How do you get things done at the different milestones? Once you decide that, you need to go in and say, what are the requirements for the system? So you need to go into different floors, talk to different users, just figure out what are the system need to do for them. So that's called requirement analysis. Now you start the program development part, which is now you're getting into nitty gritty. You need to start to do programming or coding in computer coding. To really put a computer code into something into a software you can use for your work. So you need to get into the stage of design, development, integration, and the testing and implementation. So those are the steps usually involved in program development lifecycle, which is a part of a large system development lifecycle. Then you're gonna go on to make it into operation. So you start to implement it. Then you say, well, how do we monitor or describe the tasks to maintain the information system in a production environment, including post-production and in-process review. And this position is once you hit certain milestone, you will say, well, let's review this, whether we can just release the team or relieve the team. So you need to describe the end of system activities. Emphasis is given to the proper preparation of data. Okay, so that's the steps involved in system development, and the program development is just one important part of that whole process. So the problem development cycle, as I said, from the previous slides, it's a little bit, slight difference on this slide, but you always start with the problem analysis, problem design, program coding, program debugging and the testing, as well as the program maintenance. Then once that is done, you may need to go back to the problem analysis to tackle on a different problem. So there are many different ways to develop a software. One traditional way is called the waterfall development model, which is the one we kind of see here. What it does is start from the requirements first. So they go in and collect all the requirements from the users, super users, administrators, and system developers. Then once you collect all those requirements, you need to come up with a design of the software. Then you need to start to do coding to put the design into functional software. Then you need to test the software to make sure there's no errors or bugs or any mistakes or insufficient codes in the program. Then you need to start to make them into maintenance mode. So those are the traditional waterfall development model. You always finish the previous step before you move on to the next step. So it's like a waterfall. The downside of this is it's very inflexible. So you get all the requirements, you go all the way to, let's say, testing. You can test and change some of the codes, but it's hard for you to put more requirements if once you have the software coded up. So there are some alternative ways to develop software. The one is called the spiral model, which means we don't collect all the requirements. We start small. We just have some concepts first, then code it up. Then we start to collect more requirements, then code it up again. So the key part is things will starting from small until it finish. Then you have built multiple prototypes along the way and test them along the way. So you almost finish every waterfalls. You finish multiple waterfalls until you hit a stage of implementation. So that's the difference between spiral and a waterfall, which is allow you to slowly add on more requirements if needed, instead of having all the requirements collect and finalize at the beginning. And there are other flavors of software implementation in terms of models. So some called agile development, which focus a lot on group communication and group collaboration. And the rapid application development allow you to quickly code things up and be able to add requirements later into the programming part without worrying too much about collecting all the requirements. It's similar to spiral, but it's more flexible that way. And for smaller programs and many good programmers, they just say, well, let's just code and fix later. I don't particularly recommend this. You always need to get into design part. But if you are a seasoned programmer, so once you have a problem in hand, you probably already can figure out what are some of the things you need to do to finish the programming. So it really depends on your experience on which model you want to choose. Of course, the most traditional one is the waterfall model. So as I said, the very first step of program development lifecycle is problem analysis. So what is the problem you have in hand? So the purpose is to review the specifications developed during system design and develop program specifications. So for example, in your assignment, you're required to write up a small program, be able to calculate a BMI. So you'll say, well, what is the problem? The problem is to have some data put in and create a BMI body mass index to measure whether someone is overweight or obese. So what are the input? So the input are your height and weight, and those are numeric value. It could be in the unit of kilogram or meter, or could be in a unit of pound and feet and inches. So those are the problem analysis stage you need to do. Say what are some of the inputs, what are outputs, what do we try to achieve. So documentation generated from this part is program specifications. What it does. There's a typo here. The timetable, how fast we needed to get this done. Of course, for the assignment, you need to get it done in 2 weeks. And what programming language to be used, of course, we specified here, Python. But in reality, you need to find out what language you're going to use by analyze the problem. So usually it's performed by system analysts and programmers. So if you're not in the mode to become a programmer, and many graduates in health informatics or health information management graduates, they can comfortably transition into the role of a system analysis, which means they're going to analyze what the problem in hand and provide a specifications for programmers to use in order for them to tackle the problem. So the program and design part is say, how do we design a program, do all the steps needed to complete this task. So the purpose is to determine the algorithm to be used with the final program. So it turns out there are many different approaches as well. There's two popular approach. One is the structured programming, which is step-by-step programming. The other one is to view the codes or the design as individual objects interact with each other. So there's two different flavors or two different approaches to programming, and there's others programming paradigms, including aspects-oriented programming. So you focus more on the functionalities of your program instead of on the steps. But we're going to focus on the first two in this presentation. So the design, you can have many different tools for designing your software. You can have structure charts, you can have program flow charts, and you can have pseudocodes, and you can also have data modeling. Data modeling we're going to talk about next week when we start to talk about database design, but I just want to show you some examples of these other tools. So struct charts is I look at all the problems I have, all the actions I need to take. So how do I divide them into structure and a substructure? So here is a structure charts for a payroll system, a payroll software. So here are the flow of operations within that software. So the payroll system needs to be able to generate payroll. But for me for a organization to generate a payroll, they needed to do three things, subtask. So they need to be able to get a payroll record. They need to be able to calculate the net pay as well as to print out a check. Alright? So all those small dotted arrows just tell you what happened is at the end of payroll you need to validate the records, and for generative payroll you also need to validate the records and the payroll check dates, and here you need to send the payroll check dates to print a check, and print a check function needs to send a check printed signal to generative payroll. And for get payroll records, you needed to read payroll record. So this function will call the read payroll records. Once it's called, the read payroll record will send payroll records as well as I'm not sure what EOF mean here, but that's something this function needs to send to the get payroll record. On the other hand, you also needed to validate a payroll record. So get a payroll record function will need to be able to send payroll records to validate the payroll records. Then the validated payroll record needs to be able to tell get a payroll record, say, well, the record is validated. So by doing this, you can see how the data needs to be flow across different parts of your software. So that's one way to design your program. And also, there are some other tools. One is the flowchart. Flowchart is to use symbols, icons, as well as the arrows to show you how the information, how the program is going to flow through the entire process. So here is again, that's a payroll flowchart logic to read personnel file to decide how many people actually working in the company or in the organization has computer experience as well as long work experience larger than 5 years, and we want the name of those people. So if you read the flowcharts, it tells you, well, what each individual symbol means. So if this is an oval symbol, it means start or stop program. If it's a diamond, it's a decision, which means you're going to say yes or no or multiple choices. And for every rectangle, it's a process, and flow line is the arrow, and input output is a shape here, and also connectors is the dots to allow you to connect a different spot during the workflow. So if you read this program, it has a start, then it has a process called set counter to 0 because he wanted to count how many people has computer experience, as well as at least 5 years working experience in the organization. Let me get the pen. All right. So the next one is the input-output part. You need to read somewhere. So read an employee record. All right. Then you read a record. We don't know what the format of record is, but all you need to just read a record. You don't need to worry about the details at this stage. Then you say, here's a decision node. You wanted to see whether there's any more node. If it's no, which means you ought to read at the end of all your records, so you just print out counters. If it's yes, say, well, I still have more records. Well, let's just look at the current one we have. All right, does this person has a computer experience? If it's no, we're gonna just move on to read another records. So here's another line which is actually did not show here. So we'll just read another records, gonna swing all the way back to read another records. If the person has computer experience, that's wonderful. So can we check to see whether the person has larger than 5 years working experience? If it's no, which means it doesn't fit our requirements, then we'll just read another record. Let's skip that person. If it's a yes, we need to print out the person's name. Okay, that's wonderful. Then we add 1 to the counter. Remember, we set a counter to 1. So we add 1 to the counter, which means we're going to continue on to count the person who has computer experience as well as 5-year working experience. Then just continue. Once this one is done, you can go down, read another record. So just continue the loop until, here's how you break out the loop. If there's no more record, you're going to print out a counter. So this is the decision, very important decision. I'll just say, if it's yes, we'll continue to do the loop to read more records. But if it's no, we just get out of here and print out the counters. And all those can be translated easily into a pseudocode, which means it's it looks like a computer software, but it's not. It's a mix of computer programming language as well as general English language, allow you to quickly figure out what you want to do. So here are some things that will start counter equals to 0. It looks very computational. Now here's a read a record. Okay, so I don't really need to know the details until later when I give that to the programmers. So do while, of course, it has a strong computer science, computer language flavor. Do while something happens. So here's another part of English. So there are more records to process. So if computer experience, if this one is larger than 5 years, company service larger than 5 years, just print out the name and an incremental counter. So you don't even need to know how to increment a counter. You just set it there. If not, else, which means else. Then next statement. Then and if. Then again, here's another else corresponding to this if. So which means the person doesn't have computer experience. Then we move on to the next statement, or it should be next record. Then and if, and read another record. Then and do, which means finish this part. So you can see we use the indentation to see which keywords are corresponding to the keywords on the top. Okay. Then we print out the counter and a stop. So this is equivalent to the flowchart, the pseudocode. And another way to look at all the software, development, instead of doing the step-by-step, we look at the different parts as different objects. And here's an important concept is between classes and objects. So classes is more like an abstract concept related to objects. For example, every student is an individual object. So student A and student B, they're two different students. They have different names. They have different arrays, they have different grades, those kind of things. But on top of that, they are all students, right? It's a very abstract concept of students. So for every student, they need to have certain features like age, gender, GPA, major, those kind of things. But you don't have any value related to that because it's very abstract concept. But there's a concept here is if you instantialize your classes, you create objects. Okay, so I'm gonna say that one more time. If you instantialize a class and you get one object, so for example, I can instantialize multiple objects, student objects, to make student 1, 2, 3, 4, 5. So for every student, I just have different values associated to the variables should have for that students. Of course, in this slides, the example we use here is the example of bike. Okay, so bike in general, or bicycle in general, is a class. So for every bicycle, usually we have 2 wheels, we need to have pedals, and there's no motor, and the seats for riders. However, once you needed to have individual classes, you need to have more values defined. So here in bike 1, I define the current speed is this, current cadence is this. I'm not a biker, I don't even know what that means. And the number of gears, number of current gears. Then for bike 2, it has different speed, different cadence, number of gears, and different current gears. So this is just a different way allow programs look at different parts in your program. So for example, in an EMR system, it could be for every patient, the individual patient is an object. Alright, so it has different properties or different variables needs to be associated with that a class. So patients in overall is a class. Then you just instantialize your class to create individual patients. So patient A, B, C, D, and E. We give them different values for their properties as well as their variables. Now you can have that interaction if you need it in terms of programming it. So flowchart, pseudocode, object-oriented data modeling, as well as data modeling, relational data modeling, we're going to cover in next couple of weeks. There are different ways of viewing the real world and try to translate it into a more structured and abstract way of looking at or organizing the real world. So in terms of computer design, you probably already see that we have different control structure, and the three big ones are sequence, selection, and repetition. So sequence is easy to understand. Step 1, step 2, step 3. Selection is oftentimes you see the keywords if, then, else, or if, else, or case. And repetition, oftentimes you see do, until, do, while, as well as a for loop. So for example, here is a sequence flow chart. So procedure 1, procedure 2, procedure 3. Then here is a selection. If it's binary selection, usually you just use if else, or you can stack up multiple if else statement together to make it a multiple selections. But there's a quick way is just to use case. So case will usually allow you to judge on 3 or more than 2 conditions. So for example, in your assignment 1, if you calculate BMR and try to measure whether someone is overweight, underweight, normal, or obese, it's actually give you 4 conditions you needed to measure. So you can use 4 if statements, or you can use case statements here. So here's an entry, here's a condition. If yes, we do this. If no, we do this. Then we go on to exit the condition. The next one is the same, but instead of 2 conditions, we have 3. So we're going to judge based on whether the value meets any conditions. We just go on to the next step. And the loops is allow you to just keep running the things until a condition is met. So do while allow you to do the loop, to have the loop as long as you or the program meets the conditions. If it doesn't meet condition, it break out the loop. So here is actually the condition is very important. If you don't think about your program or design your program carefully, you may end up in an infinite loop, because if you're never gonna have a condition to be met as no, which means you can never get out of this loop. And the do until is you keep doing this until the condition is true. So this is the difference between do while and do until. Do while is you keep doing this until the condition is false, and do until is keep doing this until the condition is true. And the for loop is usually allow you to predefine how many loops you want to do. So instead of having a condition, you just say from 1 to 10 I want to run 10 loops. So that you use for loop for that purpose. So a good program design needs to be very specific. It needs to have one entry point and one exit point, and there's no infinite loop or logic arrows in your program design. So usually the documentation is the things we've seen before is flowcharts, pseudocodes, structure charts, those kind of thing. Now getting into the nitty-gritty part of coding, which how do you write up your actual programming steps using a programming language. So how do you choose your programming language? It's actually a very it's a question a lot of times people are faced in order to decide what language they want to use in order to finish their program. So you need to see whether it fits your suitability, which means whether you will have or whether it suits your needs. All right. So if you wanted to do object-oriented programming, you probably don't want to use the original the C language, which is more geared towards the structured type of programming. And you want to see what current language you use in other program, whether you can integrate that in your current system. Then you want to see what's the standards in the industry using it. And oftentimes, for example, if you work in a bank system, they still have the legacy system and use the language called COBOL. And you probably still need someone to be able to do the COBOL programming here. So you need to also need to see what kind of programs you can hire to have to employ in order to employ to finish the task. So if the programmer is only good at Visual Basic, then your programming, and it also fits your other needs, then maybe your program should be written just in Visual Basic. And portability, whether the program is portable to other system, and how fast do you want it to develop the system. For script language, usually it's like Python, usually it's fast, but for some other more structured or more formal language like Java, the development speed sometimes is just slower than using the quick and nifty script language. So those are the factors that you needed to consider before you decide what language you use. And there's some good practice in programming. One is you need to put comments here. The value of comments is to the comments won't be run when the program is executed by the computer, but the comments is basically in the code allow programmers to view what the part of the program is about. So in this case, you can see all those included in the asterisks. They are actually not the codes will be executed, but it tells you what this program is doing, how many inputs it has, what's the outputs, and what is the results, what is the outputs, and who wrote that in which year. And you can see what's the variable list. And here are some of the things. It could be some of the codes you got to comment out, which means it won't be run, but you wanted to keep there just in case you need to go back to the previous code. Then there's some, coding is to use reusable code. Oftentimes we write functions for that purpose, so we can call functions again and again as a block of codes we use multiple times instead of writing the same codes again and again in different parts of your program. And in database, you needed to have a data dictionary to tell people what your data is about. So if you say name, you need to say, well, here is the full name or last name or first name. Okay. Then translating code programming into executable code. That's the part. There's three different ways of doing that. Compile your code, interpret your code, or assemble your code. Assemble is a kind of old concept when we use a language called assembly language, which is very close to the language computer machine can understand, which is 0 and 1s. But the compiler and the interpreter are the two big school of programming language. The compilers is for the compiler is to compile a program. So what does that mean? Is to translate all the codes into a machine readable format, which is 0 and 1. And interpret, instead of using compiler, they use an interpreter, which they translate your codes into a predefined scripts, then execute on machines by the computers. So the next slides show you the difference. So everything you write is called a source code. All right. So if you use compiler right here, so once you finish your coding, you just compile it. Usually, most of the programming tools allow you to do that. So you compile them and change those into executable codes that the computer can understand. So the whole thing is called compilation. The interpreter language, like the Python language we use, instead of change that into executable code, it changes into intermediate codes, which are predefined executable codes. Then we'll run on top of an interpreter, and the interpreter going to communicate with the machine. All right. So the benefits of interpreter language is oftentimes it can be platform independent. So if you develop something for a Windows system, usually you can use that for a Mac system as well, because you don't worry about what's going to happen between your code and the machine. In between, you have an interpreter allow the machine. They will translate your codes. Then they will communicate with the machine to execute it. The downside is because you don't develop or compile things into machine language for that platform, what happens is usually it will be slower than compilable language. So those are the two big difference between the compiled language and the interpreted language. Oftentimes the modern language will adopt the two modes together, so you can compile your code, but if you wanted to just want to quickly have some prototype, don't care much about the speed, you can certainly interpret. You can use the interpreter mode of your programming as well. So then next step, once you have the program, you need to test your program. It's often a process called debugging. So to make sure there's no errors or minimize the number of errors. So the errors could be the syntax error. You have a spelling wrong, you spelled keywords wrong, or you spelled a variable name wrong. Oftentimes it's going to happen when you program your assignment. And the logical error is something you have a wrong formula, wrong relational operators, and you didn't design a definition, you didn't design a condition well, so there's no way the software or the program can meet that condition, then causing you to have infinite loop. And oftentimes you can do is to at the different steps in your program, you can do dummy printing statement, allow you to see what's the value of the variables now, so I can find out what are some of the things wrong related to my program, what I want to do. So here is an example of a syntax error. So the input is actually misspelled. Instead of INPUT, it was spelled as INPPUT, so it's a misspelled words. Then here's a logical error. You actually here's a logical error. What we try to do here is, so here is actually a wrong formula. You wanted to add two numbers, but once you just enter one, it will do the output here. So you wanted to be able to have it like this. Wait until the second number is entered, then you can do the then you can add them up. So in the program, you can put those dummy printing statements, allow you to see the output along the way. Then you can figure out what's wrong with your code. So in this case, you actually needs to have a condition, say if it's less than 2, which means if you only have one number, you don't want to add them up. You need to wait until the second time to have the number entered. So here, how we use pseudo statement, a pseudo print statement to find out what's wrong with the code. Then debugging and testing have different stage. There's a stage called alpha testing or beta testing. Alpha testing is something happen within your organization. Beta testing is to test them using the public users. So oftentimes when you see a new operating system come out, they say, well, we start our beta test or start our public test, allow general users to use their software to give them feedbacks. So documentation in this stage is a completed program package. So maintain your program is also important. You need to continue to get information about, once you start to push out to the market, you need to collect information from the users, say, well, some of the features you need to change, some of the security holes, those kind of things. Then you can give back to your programmers to allow them to do updates on the programs in order for them to be more secure, more efficient, much better, then can be pushed out at different version time. And one unique thing about EMRs, EMR is a system software. Every hospital runs differently, and every hospital is going to have different requirements on EMRs. So you will have some unique for your organization, unique features you wanted to have, which oftentimes EMRs will allow you to have different switch. So hundreds of switches allow you to turn on and turn off some features. But if you really want to get under the hood, you have to submit a request, and they will collect all the requests from all the organizations have their software installed to be able to give you a upgrade. So that's why you can't just say, well, I want this changed, especially if you're using a system from a vendor like Epic. It won't happen overnight. It needs to wait until they collect enough data or requirements and be able to build into their next version of software. So there are many different ways you can use for your software development. The easiest way is just use text editor, start to write up your code, and you can many other tools allow you to do the similar task quickly. So for example, you can use Micro Recorder. If you use Microsoft Office Suite, there is something called Micro Recorder, allow you to record all the steps you need for certain tasks. So next time you use it, just click one button, will finish all your tasks in one click. There's things like report and form generator, even some code generator. If you write up your pseudocode, it will generate most of the computer codes for you. Then you can just put in the details. And there are some terms you may want to know: CASE, SAM, RAD. So CASE stands for Computer Aided Software Engineering. There's tools for that. CASE tool. The Software Assets Management tool allow you to manage different softwares, and rapid application development, those kind of things. So that's the part related to the introduction to software engineering, software development, program development. So stay tuned for the next section.